Hey, welcome back. Now we're going to apply everything we've kind of been working on with radicals to equations. So solving equations that have radicals, basically. Okay, so it'll just come down to taking the square of both sides. So if you have a square root, then you do the square on both sides. If you have a cube root, do a cube both sides, etc. So here's an example of kind of a simple version of this problem. We have square root of x equals 9. So we'll square both sides. And on the left, we'll have x. And then on the right, it'll be 81. That'll be our solution. Unfortunately, though, in these situations where you're raising both sides of the equations to an even power, you have to check your solutions. Okay, so just note when raising both sides of equation to an even power, we must check solutions. Okay, so let's take a look at some of these problems. Here's number 2. Make sure I got the mic aligned correctly. Okay, so here's number 2. Square root of 5x minus 1 equals 8. So to get rid of the square root, you're just going to square both sides. On the left, you get 5x minus 1. On the right, you have 64. Solve this result. Okay, so I have 5x equals 65. Divide both sides by 5. And you get x is 13. Okay, then we need to check this thing. And we have to check in the original expression. So before we took the square on both sides, before we squared both sides. Okay, so I have to plop the 13 into the original equation, this thing. Okay, so I'm going to put 13 in there. 5 times 13, 5, carry the 1 is 65, minus 1. Square root of 6, so that ended up being the square root of 64. And then the square root of 64 is 8. Okay, both sides are 8, so that's a true statement. So therefore, it is the solution. Okay. Let's look at another one. So we have number 6. And I have the square root of 2x plus 5 plus 11 equals 6. Okay. So we always want to get our expression, hopefully, ideally, into the form where we have a radical on one side and all the other junk on the other side. Okay, because then we could square and get rid of the radical. So first I'm going to move the 11 to the other side. So I have the square root 2x plus 5 equals negative 5. Now I'm going to square both sides. Okay, so I have 2x plus 5. It gets rid of the square root. The other side, negative 5 times negative 5 is 25. Move the 5 over. Divide both sides by 2. Okay, and then I'm putting 10 into the original equation. So I'm going to plug it into this equation. Right, so square root of 2 times 10 is 20 plus 5 is 25. Square root of 25 is 5. And in this case, I got a false expression, okay, or false equation, I guess. When that happens, that means that your given value is not a solution. Okay, so this false statement means that this thing does not work. There were no other solutions, so therefore we have no solutions in this problem. Okay, so let me kind of give you the standard procedure. First, try to isolate the radical. It's not always possible because sometimes you have multiple radicals, and we'll see how to deal with that here later. Then secondly, you want to raise both sides to the nth power. So we might not always be dealing with square roots. We may have cube roots, fourth roots, sixth roots. So if you have a sixth root, you need to raise both sides to the sixth power. Okay, so that's what I mean by raise both sides to the nth power. Okay. If that n value is even, so if n is even, you must check your solutions. Okay. And then thirdly, of course, once you've raised both sides, hopefully you'll be able to solve. If not, you may have to raise both sides to power again, but we'll see how that works here in the future. Okay. So anyways, here's number 12. I have x equals the square root of 3x plus 7 minus 3. Okay, so I want to isolate this radical expression. I'm trying to get a different color there. This thing. So I'm going to add 3 to both sides. So I have x plus 3 equals square root of 3x plus 7. Now I'll square both sides. On the left I have to FOIL. So I have x squared plus 6x plus 9. On the right I have 3x plus 7. This is a quadratic equation, so I'm going to move everything to one side to set it equal to 0. So I'll have x squared plus 6x minus 3x is 3x. 9 minus 7 is 2. And then you need to factor this thing. Looks like 2 and 1. Okay, equals 0. Set each part equal to 0, so x plus 2 equals 0, and x plus 1 equals 0, and then solve those equations. And then we have to check each one of those answers. Okay, so I'll try x is negative 2 first, and you have to plug it into the original equation before you did any sort of manipulations. Okay, so I'll have negative 2 equals the square root of negative 2 times 3 is negative 6 plus 7 is 1. Okay, so negative 2 square root of 1 is 1. And then negative 2 is negative 2. That works. So that's a solution. Sorry, I did that in red. Let's try negative 1, see if that works. So I have negative 1 equals the square root. 3 times negative 1 is negative 3 plus 7 is 4. And then minus 3 equals 2 minus 3. Negative 1 is negative 1. So yeah, they're both solutions. They both work. Okay. Let's try 18. So this time I have a cube root. Cube root of 6x minus 3 equals 3. So, and in this case, you raise both sides to the third power. And that'll get rid of the cube root on the left. On the right, 3 times 3 is 9, times 3 is 27. Add 3 to both sides. Divide by 6. And you don't have to check your answer when you have an odd power. Okay. Let's try 22. So 22 is going to be one of these ones where you're going to have to basically square it twice. Okay, because you'll have 2 roots. So it's not possible to just put all the roots on one side and then square that, because you'd end up having to FOIL it, and you're not going to be able to get the square roots to go away. So the way you're going to handle this is just, you kind of square both sides. On the left, of course, the square root will go away, but on the right, you have to FOIL that thing out. So, square root x minus 2 squared is square root x minus 2 times square root x minus 2. And you'll end up with first square root x times square root x is x. The outer negative 2x, the inner negative 2x give you negative 4, and it's square root x, not just x. And then the last give you plus 4. So the issue is you've squared, but you still have a square root. So how do I deal with that? You're just going to isolate the square root portion, and then square both sides again. Okay. So what I'm going to do in order to get this to work out nicely is add that thing to the other side, and then move the x minus 8 to the other side. So we'll have 4 square root x equals, subtracting x from both sides, the x's will cancel, add 8 to both sides, and you'll get 12, I believe. Then you can divide both sides by 4, so you get the square root of x equals 3. And then you can finally square both sides again, and you'll have your answer, or potential answer, because you still have to check it. Okay, so x is equal to 9. Okay, and then all you have to do is plop that into the original equation. So I have square root of 9 minus 8 is 1, equals the square root of 9 minus 2. Square root of 1 is 1. On the right hand side, square root of 9 is 3 minus 2. 1 equals 1. That's true, so this is our solution. Okay. Let's look at one with a funny power. So number 30. Here I have the fourth root of 2x plus 3, and they wrote it with a rational exponent, but it's really just a radical fourth root. Okay. So if you don't like the rational exponents, you can always convert back to the radical form. But anyways, I'm going to isolate that 2x plus 3 to the fourth power by moving the 7 to the other side. So you get 3. Then you can raise both sides to the fourth power. And you can really see why this works, because when you multiply those exponents on the left there, you get 1/4 times 4, which is 1. So you'll just have 2x plus 3 to the first power, which is just 2x plus 3. On the other side, 3 times 3 is 9, times 3 is 27, times 3 is 81. Subtract 3 on both sides, so you get 78. Divide on both sides by 2. You get 39. Then you got to go and check. So 2 times 39 is 78, plus 3 is 81 to the 1/4 plus 7, and does that equal 10? Fourth root of 81 is in fact 3. 7 plus 3 is 10. 10 equals 10, so you're good. And you have to show these checks on the test. If you say you can't just tell me you did it in your head, because I mean, I want you to show me the checks, show me the work. Okay. Otherwise, I can't give you full credit. Okay. Okay. One more problem, and this is the video quiz, and then I'll dive into the actual web assigned homework. But this is the video quiz, video quiz, video quiz. So we have square root x plus 2 plus square root 3x plus 7 equals 1. Okay, this is another one of those guys where we have more than one root, just like in 22, and you're going to end up having to square it twice. Okay, so first I'm going to move the square root 3x plus 7 to the other side. So I have square root x plus 2 equals 1 minus square root 3x plus 7. Okay, now I'm going to go ahead and square. So on the left, I'll just have x plus 2. On the right, maybe we should actually write all this out, so just in case you're having trouble following along, it'll be more clear as to what I'm doing. Okay. 1 minus square root 3x plus 7 squared is 1 minus square root of 3x plus 7 times 1 minus square root of 3x plus 7. Okay, and you have to FOIL it. So the first, you have 1 times 1 is 1. The outer will be minus root 3x plus 7. The inner will be minus, again, root 3x plus 7. And then the last, negative times negative is positive. And then you have root 3x plus 7 times root 3x plus 7, which will be root 3x plus 7 squared. So the square root will go away, and you'll just have 3x plus 7. Okay. Combining like terms then, what do we have? 3x, we have an 8, so this 1 plus 7 gives me the 8. And then there's negative 2 of these root 3x plus 7s. Okay. All right, what I'm going to do then is move this guy to the other side and then move the x plus 2's portion to the right side. So I'm going to end up with 2 root 3x plus 7 equals 3x minus x is 2x. 8 minus 2 is 6. 2x plus 6. And then you could divide both sides by 2. I'm just going to go ahead and square both sides at this point. So on the left, you'll have 2 root 3x plus 7 times 2 root 3x plus 7, which will just give you 4 times 3x plus 7. On the right, you have the FOIL. So I'll have 4x squared plus 12x plus 12x, which is 24x's, then plus 36. Okay. Now this thing is quadratic, so we want to set it equal to 0. Let me distribute first. So I have 12x plus 28 equals this 4x squared plus 24x plus 36. Subtract over to set it equal to 0. So 4x squared plus 12x plus 8. And then I think I can factor out a common factor of 4. So I'll have x squared plus 3x plus 2. And then you can factor that thing. So you get x plus 1, x plus 2. Set the parts equal to 0. The 4 will never equal 0, so you don't have to worry about that. But set the x plus 1 equals 0. That would give you x is negative 1. X plus 2 equals 0. That gave you x is negative 2. Okay. So those are our potential solutions. We're not done yet. We need to go back and do our checks. So let's try x is negative 1 first. And I have to plug it into the original primordial equation that you're given. Okay, so negative 1, and for x I get square root negative 1 plus 2 is square root 1. Plus, plug negative 1 in for x, so I get negative 3 plus 7 is square root 4. Is 1. Square root 1 is 1. Square root 4 is 2. 1 plus 2 is 3. No. So that one doesn't work. So we're going to throw that one in the trash. Let's try negative 2. So plugging in negative 2. Negative 2 plus 2 is 0. Square root of 0 is 0. Plus the square root of negative 6 plus 7 is just 1. So I have 0. Square root of 1 is 1. 0 plus 1 is 1. So that one's true, so that one works. Okay, so at the end, our only answer is negative 2. Let me throw that one in the trash. Okay, so that was your video quiz. That was the second question in homework number 6. Let's move into my math lab and see what kind of craziness they have in store for us. As usual, you could use this last part for reference. You don't necessarily have to watch it. Okay, so let's get in here. Okay, so I'm just going to sort of cruise through exercises and then pick some at random. We can handle that. We can handle that. You can handle that. You can handle that. You can handle that. No problem. Square both sides. Cube both sides. Cube both sides. Square both sides, and then you'll have to square again. Yep, same for that. Square both sides, and you have to square again. Okay. Isolate, square, solve. You're going to have to take the cube both sides eventually. You're going to have to take both sides to the 4th power. Square both sides. 1/2 is the same as a square root. You're going to have to do it twice on that one because you got the 2 roots. Let's try this one. Okay, so 3x to the 1/3 equals x squared plus 13x to the 1/3. Okay, I'm going to have to cube both sides. Okay. On the left here, you'll have 3 cubed because remember, you basically have a power. A product to a power scenario. So this would be a to the m times b to the m. So right now the exponent on 3 is 1. So you get 3 to the 3, which is 27, and then x to the 3 over 3, which would be x to the 1. On the other side, that gets rid of the cube, the 1/3 power. So you just get x squared plus 13x. And then this is quadratic, so I'm going to move the 27x over, minusing it. So you get 14x 0. Then you can factor this. And then you get x is 0 or x is 14 as your solutions. And you don't have to check it because it's an odd x. We raise both sides to an odd number. Okay. I don't want to lose my. So now the stupid thing is stuck down here. I can't get it. There it goes. Okay. Anyways, raise both sides to the fourth power. You have to check your solutions. Find all values of x for which f of x equals 5. So this is just plug and chug. So they give you f of x is x plus square root x plus 1. But all they want you to do is let f of x equal 5. And then solve that. Okay, so I'm going to isolate the radical. Square both sides. I have the FOIL on the left. Set it equal to 0. Factor. And then finally check your solutions in this equation here. Okay, so 5 equals 8 plus 1 is 9 plus 3. That don't work. So 8 gets tossed, and then try 3. Square root of 3 plus 1 is 4. And that one works. So your only solution is 3. So this one you just want to set both equations equal to each other. So you would set 6x plus 9 to the 1/3 equal to x minus 26 to the 1/3, and then cube both sides. This one's a little weird. Square root 11u all over pi times p. Square both sides, so you get r squared equals 11u all over pi p. Then multiply on both sides by pi p over 11. Okay, so on the right side you would just have a u left. On the left side you would have r squared, or whatever order you want to put it in, pi r squared p all over 11, and then that should do it. More of the same sort of stuff. Weird story problem. 3 times a number. 3 times a number is decreased by 2. The principal square root of this difference is 4 less than the number. Find the number. So it's just a matter of setting up your equation. Square both sides. Got a FOIL on the right. Set it equal to 0. Factor. I was going to say 6 and 3, but it's 9 and 2. So x is 9, x is 2. Check. 27 minus 2 is 25, and then 9 minus 4. So x equals 9 works. X equals 2, so square root 6 minus 2 is square root 4, and then over here 2 minus 2 is 4. That don't work because you're getting at negative 2 is not negative 2. So you have to throw out 2. The only solution then is 9. Find the x-intercepts of, so the x-intercept is a number where your y-coordinate is 0. Okay, so to find the x-intercept, you just basically let the y equal 0, and then we're looking for that x value. So in the context of this problem, you know, we have square root of x plus 32 minus square root of x minus 4. What it means here is to basically just take this 0 and plop it in for f of x. So you get 0 is the square root of x plus 32 minus the square root of x minus 4. Okay. This is going to be one of those ones where you got to square both sides twice. So let's square root of x plus 4 there, square root of x plus 32 here. Square both sides. So you got a FOIL on the left, so you get x plus 8 square root of x plus 16. On the right, the square root goes away. So try to get rid of, get the square root of x all by itself, so move the x and the 16 to the right. Divide both sides by 8, and so x looks like it's probably 4. You got to still check it, right? So the square root of 4 plus 32 is 36, minus the square root of 4 minus 4. Okay, so that would be 6 minus 2 minus 4, which of course is 0. So yeah, there is an x-intercept. I think you could just put in 4. I don't know if they want the coordinate though. Yeah, okay. Basketball player's hang time is the time spent in the air when shooting a basket. So T equals the square root of D all over 2. Model's hang time. So T is hang time. T in seconds in terms of the vertical distance of the player's jump. So D is jump height. Okay. What in particular, when a particular player dunked a basketball, his hang time for the shot was approximately 1.15. So T is 1.15. The other side we have square root of D all over 2. So we're trying to figure out how high did the person jump. So I'm going to multiply both sides by 2. Get square root of D equals 2.3. And then square both sides. So you get D equals 0.529. 2.3 times 2.3. Whoops, 5.29. I assume it's in, really, he jumped to that in feet? There's no way. Well, I guess, all right, yeah, people can jump that high. It's just regular feet. Well, yeah, I was thinking that sounded a bit fishy. No. Oh, it is right. I just didn't write. I didn't round it. That is one heck of a jump. Let me just say. I know that there are people out there that can literally jump over other people. And if you're under 5 foot, whatever, that person could jump over you. Okay, anyways, the graph on the right gives you some sort of health with respect to annual income, whether or not they're willing to report their health, I guess. Let me read the question. The graph on the right shows the less income people have, the more likely they are to report that their health is fair or poor. Okay. The function f of x equals negative 4.4 square root x plus 38 models the percentage of a group of people reporting fair or poor health f of x in terms of annual income x. So just write income. And f of x is percent reporting fair or poor. And thousands of dollars. Use this function to complete part A and part B below. So find f of 36. So yeah, negative 4.4. Square root of 36 is just 6. Let's go to the calculator. 4.4 times 6. So 38 minus 26.4, 11.6%. So what does that mean? It means that for people who make $36,000, 11.6% report fair or poor health. Okay. And for some reason my computer is helping me. I don't know. I don't want to see any news at all. What the heck is this thing? No, I don't want. How do you close it? Jeez, oh man. Yeah, it's the value of f of 36 is a percentage of people earning 36 grand who annually who report fair. Yeah. Okay, so now we're comparing this to the graph. So 36 should give us 11. And so we're overestimating by 0.6 percentile points. According to the model, what annual income corresponds to 10% reporting fair or poor health? So we're putting 10, oh sorry, this time we're setting f of x equal to 10 and then solving for x. Okay, so subtract the 38, you get negative 28. Divide both sides by negative 4.4. Really? Bunch of jerks. I'm just going to rewrite it as a fraction. So 28 over 4.4 equals square root x. Multiply top and bottom by 10, so you get 280 all over 44. Just because I don't like decimals in my fractions, I think it looks crazy. And then we can simplify that, so that'd be 140 all over 22. And again, that would be 70 over 11. And then we could square both sides and get whatever that is. Okay, so parentheses 70 divided by 11 and parentheses, and we need the square root of that thing. So 2.5-ish. I don't see them right. Did I square it? Oh, I square rooted it. I meant to square it. 70 divided by 11 squared. It's 40.49, so it's approximately, do not round in the round whole number. Okay, so $40,000. Another story problem about plants, apparently. F of x equals 22 to the 1/3. 22x to the 1/3 models the number of plant species f of x. Equals the number of species of plants on an island in terms of x, which is the area. X is the area of the island. There's a movie where they go out, I think it's Master and Conqueror or something. I forget the name of that movie, but there's a botanist on board or something. The doctor is also a botanist, and when they go to this they go to the Galapagos Islands, and he wants to go out on foot and like find birds and stuff. Anyways, apparently there's some sort of function now that they can tell you how many different species are out on the island. So anyways, what is the area of an island that has 44 species of plants? So in this case, they're telling you f of x is 44, and they want you to solve for x, which would be the area of the island. So x to the 1/3 is basically the cube root of x. I'm going to isolate that by dividing both sides by 22. So get 2, 44 by 22 is 2 equals x to the 1/3. Cube both sides, and you get 8. Really? 8 square miles? I guess. Okay, well, very good. Thank you for watching as usual, and we will see you in next time.